My sister's getting married in a couple of weeks, and she's asked me to make her wedding cake stand. I'm gonna make something kind of like this, I think, with the 3 little crossing support members. She's pretty worried that the cake is super heavy, so she doesn't want it to topple over when they're cutting it. I think this is gonna work. I've got some of this 12-quarter maple left over from my last project, so I'll use this to create the top and bottom. The bottom is going to be 13 inches in diameter and the top will be 18. So I'll give myself about 40 inches here. I want to end up with about an inch thick on the top and the bottom. I'll resaw this so that I've got maybe 1.25 inches, something like that. Got our panels here. Well, I got a CNC. This is an OpenBuilds 1515, and I made a custom controller, which I'm not going to show, but it's running on LinuxCNC. I think the plan here is going to be to pop these guys on the CNC and use that as a slab flattening mill. And they're only 10 inches wide at this point, so I'll be able to take them over to the planer for the other side. So we'll just whip up a quick program in Fusion here. I'll create a rectangle and we'll extrude this 1.25. And I'm going to use a 2D adaptive clearing. I actually have a 1.25 inch face mill. The cutting feed rate here, let's call it 100 inches per minute. Stock point as the corner. Take a look at our simulation and just ensure that this appears to be doing what we want it to do. And export some G code here and copy this to our LinuxCNC machine. This whole thing is running on a Raspberry Pi 4. The whole setup is pretty janky, to be perfectly honest. I don't have a touchscreen yet, so I'm using the Axis controller. And we're now in joint mode, and I need to have the machine home itself. Each axis has its own limit switch, so you can see here when this little arm gets pushed in this direction, it'll trigger that little micro switch there, and that'll, send a signal back to LinuxCNC. And now it knows where it is in space. This is the slab flattening mill that we're going to use for this operation. This one I can probably just screw down as is. It's not really twisting. This one has a bit of a rock. Hardware store shims here should do the trick. Counter bore for the screw heads. Probably around here is going to be the highest point. Ooh, that's what you call a crash. Yeah, I'll just kind of eyeball that it's about right in the X and Y direction. Touch off our X. And now we can see that the toolpath looks like it's in a pretty reasonable spot. Looks like this is our thinnest corner here, 0.90. So we'll probably try to get everything down to maybe 0.85, something like that. I think this is looking pretty good here. We do have this sort of machining pattern, so I think I am going to send it through, just skim off a little bit here. This looks quite straight and flat, and you know, when I put them on top of each other here, they kind of feel flat. They want to suction together, so it's a pretty good sign that they're reasonably flat. Now, I could grab the track saw to cut a perfectly straight edge on these things, but it's quite a bit easier to just grab a hand plane. 5.5 is long enough to make a straight edge. And just like that, I'm basically down to where everything is nice and flat. And I can feel, because it wants to twist like this, that I have a little hump in the middle. And I'm going to take a stroke in the center. And there's my full length shaving. You have the absolute slightest hollow in the center here, and I can feel that because I can kind of flex the center of this guy back and forth. Just take a little wisp off. Yeah, that's going to do nicely. If I hold the plane off to one side here, it'll actually cut just a hair more off of this side to correct that issue. Yeah, and that rock now is gone. And I'll recheck for straight. Straight enough. This one's good. I'll just do the same for the other board. So let's see how this is going to go together. Man, it looks like a pretty tight joint to me. I think that that is going to come together well. Roughly the edge of the circle here and the edge of the circle here. If anybody has any recommendations for glue that does not like stay in your clothing, stuff that'll come out in the wash, I'd love to hear about it, because you know, I do love hide glue. I think it's a great glue. The only issue being that convenience factor of having to heat it. Next morning, didn't explode, so that's good. Now we need to generate the G-code to cut out the top and the bottom. You can see, if I disable the ribs here, that we've got the tenons in here. So I want to set our stock point to be the center of the circle here. And we'll leave some tabs. I should mention, I've given absolutely zero effort to making sure that this spoil board is flat. Looks like right about here is going to be our center. So here, I can touch it off at 4 thousandths. It basically looks like we're oriented in the right spot. looking pretty good. Just zip off these tabs here. I think that looks pretty good to me. Not maybe exactly as wide of a chamfer as I'd modeled, but the pucker factor is getting pretty high here. It's a pretty big cut.
Now it's time for the ribs. I've got some more leftover material, and I'll process it with the normal power tools. I'm using the CNC to cut out the shape in 2 dimensions, but the tenons themselves can't be cut in this orientation. I could try and do something fancy to hold these parts vertically, but I think just cutting the tenons by hand will be easier. This is pretty sketchy, so I wouldn't recommend it, but I'm referencing the end of the tenon here against the table saw fence to define the shoulder of the tenon. I can rough away most of the tenon cheeks with the crosscut sled.
So the trick here is that this thing wants to tip that way, but you want to keep all the pressure, like all of your effort is going to be keeping it flat against the surface here. So all the force on that hand. You just want to glide it across. Yeah, there you go. We're just taking a tiny bit off at this point because we want to fine tune it. There you go.
I use a chisel to clean up the tenons, and also to square off the mortises.
It's going to be close enough.
Nice.
Yeah, that's going in.
Perfect.
Yep.
I used epoxy to glue it all up, because epoxy tends to lubricate the joints and make assembly easier. There wasn't really a good way to clamp this up, so I relied on the mortises being pretty tight to the tenons to hold everything together while the epoxy dries. Anyway, the cake stand was a pretty big hit. It held the cake up. Julie was concerned that we might forget it at the wedding venue, so she personally took it back to the cabin where she and Eric were staying. Somehow she managed to leave it there when she left to go back home. She got it shipped back to her though, so it's safely back home. Well, hope you enjoyed following along with the process. Thank you very much for watching, and I'll see you next time.